Hello and good evening. It is Sunday, May 23rd at 7:30, and this is the UMGC CMIT-455-6380 course meeting for the week. And so I'm going to go ahead and go for an hour covering some of the more complicated aspects of the material that we've covered throughout the first week and that we're currently covering as part of this first week. And so right out of the gate, we're going to be hit with a discussion of spanning tree. And what that means is we're going to be discussing all about layer 2. I'm going to be talking about the legacy or the original IEEE version of spanning tree, 802.1d. I'm going to be explaining why Cisco decided to use sort of their own secret sauce. And they're kind of doing their own thing with spanning tree. And we're going to talk about pvst and pvst plus. I'm also going to talk about rapid spanning tree protocol, and that would be what Cisco refers to as rpvst, or rapid per VLAN spanning tree, and rapid per VLAN spanning tree plus. I've got a couple of demonstrations I'm going to show you using both physical Cisco switches as well as Cisco modeling labs, so that we can sort of discuss some of the architectural considerations that you might make when it comes time to determine what version of spanning tree you want to run. So let's go ahead and dive in and take a look at the physical Cisco 29 switches that I have here in my lab. And you can see I've got access layer switch 01 as well as access layer switch 02. So if I go from user exec to privilege exec, let's go ahead and start out by simply saying show spanning tree. And this is going to show me the spanning tree configuration on this device. Now, in this video, the ports that we're really interested in here are these 16 ports. And when we transition into our conversation about Etherchannel and creating redundancy and putting together aggregate bandwidth, in other words, taking multiple physical ports and combining those into a single logical port. And I'll go over that information as well. So port fast Ethernet 01 and 03, those have some other things plugged into them. And we're not going to worry about those right now, although we can see that we've got an inconsistent issue here on fast Ethernet 03. So when I say show spanning tree, that's sort of the first spanning tree command that you're going to go to. And you can see here it says spanning tree enabled, protocol is IEEE. You could also say show spanning tree summary. And this is going to show us something else here. It's going to say the switch is in pvst mode, or per VLAN spanning tree mode. So I'm going to bring the drawing tool out. We're going to go to our blackboard here, and let's talk about the iterations of the spanning tree protocol. Right now, spanning tree was originally created by a woman, absolutely brilliant. Her name is Radia Perlman. And I'm going to give you, in the description of this video below, you're going to have a link to a Network Collective interview, 37 minutes long, worth every second, where the folks at Network Collective interview Radia Perlman about spanning tree, how she came up with it, what she was thinking, the problem she was trying to solve. And it is a really, really great 37 minutes to watch. So let's go ahead and we'll sort of fast forward to after Radia Perlman created spanning tree and the IEEE decided to standardize it. Now, remember, Cisco also was kind of tinkering with spanning tree. So let's go ahead and say 802.1d, and the D is capitalized. And this is important. Those, whether it's uppercase or lowercase, makes a difference with the IEEE. So 802.1d was your IEEE sort of first standardized version of the spanning tree protocol. Now, there was one problem with the 802.1d IEEE spanning tree standard, and that was that all of the VLANs that existed in a single instance of spanning tree. In other words, if you had 1,000 VLANs, all of those VLANs were in one spanning tree instance. And so what that would mean is that all 1,000 VLANs would follow the same spanning tree. And we'll talk about the system priority or the bridge priority. We'll talk about the root bridge election. We'll talk about root ports and designated ports and blocking ports. But remember, with this original version, there was a common spanning tree for all VLANs. In fact, CST is sometimes how you'll hear this referred to. Now, it's important to point out that when we're talking about spanning tree, we're really talking about loop freedom, right? How are we going to guarantee loop freedom at layer 2? Because unlike layer 3, where an IP packet has a time to live of 255, with spanning tree at layer 2, the frame has no time to live, meaning the frame will simply circle the network, and that can cause problems. So the first version of spanning tree that was standardized, IEEE 802.1 capital D. Now, this no longer exists in the current IEEE standard for 802, and it was all folded into 802.1Q. And this is no longer in existence because while this was good at the time, they definitely needed to improve things. In fact, it was Cisco who said, well, I think it's great that we've got this spanning tree thing. However, it's not a good thing that all VLANs run in a single spanning tree instance. Because in a network, and let me go ahead and let's draw some network switches here. If I had this distribution layer switch here, and this distribution layer switch here, and I'll just say D1 and D2, and I apologize, the color's a little dark there. And then we have access layer switch 1. Now, if access layer switch 1 is connected to both D1 and D2 for redundancy, and let's say that these are connected together, one of the drawbacks, as I had said, was that there was only a single spanning tree topology, meaning whichever switch was the root bridge, the topology would be built based on that, and then all 1,000 VLANs would follow whatever that path was. And so let's go ahead and we'll do it with yellow. Let's say that this is our root bridge. Well, if that's the root bridge, this is a designated port because all of the ports on the root bridge are designated ports. Now, we're talking about a single VLAN here, right? We'll say it's VLAN 1 with common spanning tree. Even if we had 1,000 VLANs, we would be talking about the same thing because there's no way to load balance. So those would be my designated ports. This would be the root port of distribution layer switch 2. This would be the root port because it has the lowest root path cost to get to the root bridge. Again, we'll say these links are all the same speed. Let's say they're all a gigabit, right? So when we look at this, we now get down to this segment here, and the root path cost of D2 is the same as A1 to get to the root bridge. And so they're sending bpdus on this segment here, trying to determine who is going to have the port that is the designated port, and then who is going to have the port that's blocking. So we're simply going to say that D2 has the superior bridge protocol data unit. And let's go ahead and say it simply has a lower MAC address, right? So this would be our designated port, and this would be the alternate blocking port right here, because that is preventing the loop at layer 2. Now, if this is true, and we're running 802.1D, which Cisco has their implementation referred to as pvst, per VLAN spanning tree. And we'll talk about that in a second. But if we were running 1,000 VLANs and we had the IEEE common spanning tree 802.1d where all VLANs are in the same spanning tree topology, then all 1,000 VLANs would go this direction off this. If say, you know, they were coming up here to the access layer switch, they would all go that direction, right? And so this link over here is just sitting there doing nothing, waiting for this link over here to fail possibly, right? So Cisco recognized this right out of the gate. And Cisco made the pitch that what should really be done with 802.1d, the IEEE standard, is that it should be per VLAN spanning tree. And that's what pvst stands for. And it's the PV that's the key here, per VLAN. So whereas the IEEE said, we're going to have a single spanning tree instance irrespective of the number of VLANs that exist. And like we saw over here with our yellow example, if D1 is the root bridge, all 1,000 VLANs that would come up here through the access layer switch, let's say, are going to go to the left-hand side of the topology with no traffic going to the right-hand side. Because again, we're blocking that link anyway. And Cisco said, well, what if you could have 500 of the VLANs, half of them take the left-hand path and the other 500 take the right-hand path? We could do load balancing on a per VLAN basis. And so Cisco presented pvst and what is today known as pvst+. And I'm going to break this down for you here in just a second. So spanning tree is running across our trunk links here, right? And we would be trunking between these switches. Well, there are two, or I should say there were two types of trunking encapsulation. The first was Cisco's proprietary ISL. And on current Cisco switches, this doesn't even exist. It does exist on the older 3560s or the 3750s. You'll find ISL. However, on the newer switches, everything is 802.1q, right? 802.1q. And that is the predominant trunking protocol that's in use because it's an open standard. The problem with ISL was that ISL was Cisco proprietary, whereas the IEEE said, well, we're going to come out with a standardized version. So Cisco, as they often do, and as you'll see here in the run-up to multiple spanning tree, Cisco took the IEEE standard and said, okay, you guys are going to standardize 802.1d with the IEEE. You're going to make that standard, and it's going to have a single spanning tree instance for all VLANs. But we at Cisco, we believe this to be a better approach because we don't want all 1,000 VLANs to follow the same path, a single spanning tree topology. We want the ability to load balance with the VLANs. In other words, as I just said, we want to be able to send 500 of the VLANs to the left and 500 of the VLANs to the right. And so what might that look like? Well, we just did yellow. Now I'm going to go ahead and do green. So if this is the root bridge here, D1, and let me get a little brighter color here. Let's do sky blue. So if in the yellow, right, and this was our common spanning tree example where all 500 VLANs would go to the left. Now let's go ahead and let's talk about Cisco's pvst and pvst+. Keep in mind that today it's pvst+ because 802.1q is the trunking protocol on Cisco switches, right? On older switches, it's not. So Cisco said, okay, well, this is great here, right? Where what we have in yellow, but we want the option to maybe peel off half of those VLANs and say that this is the root bridge for VLANs. And let's do it over here. We'll just say, you know, B for blue, and it's going to be VLANs 250 to 500. And that's what we want to do. And I ran out of space there. And then we'll say for yellow, let me change it back to yellow. So say for yellow, that's going to be the spanning tree topology for VLANs 1 to 249. Right? So we're basically splitting them in half. And we can do that when we're using Cisco's per VLAN spanning tree. So if this is the root bridge, that would mean that this port would be a designated port, because remember, on the root bridge for the VLANs in question, all ports are the root ports. And again, we're kind of talking about a series of VLANs here. Oops, sorry, I didn't want the R there. Let me take that back. So this would also be a designated port, because all the ports on the root bridge are designated ports for the VLANs in question. Meaning this would be a root port here because D1 is closest, i.e. lowest cost, lowest root path cost is this directly connected gigabit Ethernet link. And so that means here, this would be the root port, meaning we've got this segment over here and we need to determine which port is going to be the designated port and which port would be the blocking alternate, sort of standby port. And so the way that we do that is we first say between A1 and D1, who has the lowest root path cost? Who's got the shortest path to the root bridge? Well, for the blue VLANs, it's equal, right? They both have a root path cost here that is going to be equal. So we go to the next criteria. And the next criteria is superior bpdu. And let's go ahead and say that it's D1, meaning for this segment, that's going to be my designated port, and this will be the alternate blocking port. Now, when you look at this and you say, okay, so the yellow VLANs, they're going to go to the left-hand side. When we look at blue VLAN traffic, you know, and when these arrows here represent, it could be PCs, access points, whatever we have, all these things we have plugged in at the access layer. And let's just say, again, we're assuming 500 VLANs, right? So the blue traffic is going to go that direction for those blue VLANs, 250 to 500, because we make this the root bridge, D2 we make it the root bridge, and we make D1 the root bridge for the yellow VLANs, because we can do per VLAN spanning tree. And that's what we're seeing on the switches that we're looking at here. Right? So if I come back over here and say show spanning tree summary, that is why it says the switch is in pvst mode. And again, this is an older 2960. And so we see that it's pvst mode. Now, we can load balance per VLAN, and we think that's, and we think that that's a great idea, right? But we kind of run into a challenge because we now have an instance of spanning tree for every single VLAN. So the 802.1d standard said we have one spanning tree instance and we're going to pack every VLAN in there. Cisco went to the other end of the spectrum and said, no, 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 we're going to do a single instance of spanning tree for every single VLAN. So if you have 1,000 VLANs like we do here in our theoretical topology, we would have 1,000 instances of spanning tree. So it literally went from one extreme with the IEEE saying one instance of spanning tree for every single VLAN to Cisco saying, no, 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 one instance of spanning tree for each and every VLAN. So if this was an IEEE 802.1d setup, we'd have one instance of spanning tree, all 1,000 VLANs would follow the same topology. If this is PVST, and I'll just say PVST plus. If I say PVST, I mean PVST plus, because that's what it is today. So if this was PVST with Cisco, we would have 500 instances of spanning tree run. I'm sorry, Yeah, I said 500 instances of spanning tree running in this topology, one for every single VLAN. But it gives us the ability to do this. So this is where things started out. And then it was quickly learned that the legacy 802.1 spanning tree and pvst and pvst plus did not really converge quickly, that there were a lot of problems. It solved the looping problem at layer 2, but then there were some other issues that came up. And so Cisco said, we need to take some of what we call our spanning tree toolkit. And let me pull that link up right now. And I'm going to include this in the write-up that we have later on. Spanning Tree Toolkit Cisco. Whoops. And this is a great PDF that's out there. Again, it's a much older document. And some of these features are still around, as you'll see. But then there are a couple that are gone that were rolled into the latest version of Spanning Tree. And so here is the Cisco Spanning Tree Toolkit, because again, Cisco realized there were weaknesses and there were drawbacks to pvst, right? Which again is based on the IEEE standard 802.1d. Cisco just said, well, we're going to make it per VLAN. But then Cisco said, you know what? We're going to do this thing called port fast, which you put on server or PC or in-device ports, where the port skips the listening and learning states. Now, we'll refer to these as port fast ports when we start to talk about rapid spanning tree protocol. They're really referred to as edge ports, devices that are at the edge. In other words, devices not connected to other switch devices, right? And this was a very effective way to have the hosts come up right away. You might be thinking, well, what difference does it make if it takes 30 seconds for the port to come online? Well, what if it's a DHCP server, right? Or a DHCP client trying to make a request? System may time out and not get a DHCP address. And so port fast is there to do that. Then you've got uplink fast and backbone fast. These are the two features, uplink fast and backbone fast, that were rolled into the rapid spanning tree protocol, which is 802.1w, right? And that was the next iteration of the spanning tree protocol. So those got rolled in there. We've got bpdu filter, bpdu guard, and root guard. Those are still around today, and so is loop guard, right? And so I'm going to give you the link to this document. And this is, again, it's a very, very good document, albeit a little bit old, because it talks about the advantages of each of these features, keeping in mind that uplink fast and backbone fast are gone. They're included, right? They got included in the standard. And a quick note here, this is the link I'll be providing. And down in the lower right-hand box here, that is Radia Perlman. And the Network Collective site is amazing. This is one of the best blogs that's out there. In the lower right-hand corner is Russ White. He is a legend at Cisco in the routing space, without a doubt. And he is in a lot of these sessions as well. So I highly recommend this. Again, I'll be including that link so that you'll be able to access this. And so let's take a step back now and let's go back to our conversation here. So Cisco saw that there were a lot of drawbacks to the original version. Again, it was kind of the first swag for everybody at trying to figure out how do we get this to work. And, you know, then they implemented it and then it goes out into production environments and they start having some challenges. And that's when the IEEE, again, sort of following Cisco's lead, said, you know what, we need to come up with something better as a standard. So we're going to standardize 802.1w, and we're going to call it rstp. And this is the IEEE standard 802.1w, and it is referred to as rstp. And that stands for Rapid Spanning Tree Protocol. And the key being the R, because it did take, you could end up with some convergence challenges with legacy spanning tree. So Cisco again lobbied to get their per VLAN version of what this protocol was going to be the standard. But the IEEE said, no, thank you. We're going to continue to standardize with rstp so that for all the VLANs, there is a single spanning tree instance. So they basically included backbone fast and uplink fast and a lot of major improvements, right, to make it rapid. However, they kept their thinking and ideology with a single instance of spanning tree for all VLANs. So Cisco said, not going to work for us. And Cisco said, we like the ability to do rapid per VLAN spanning tree. And this was when you had ISL as the encapsulation on your trunk links. And then it was, as you might guess, rapid per VLAN spanning tree plus. And this was Cisco's implementation. And so again, making sure that it was compatible with rapid spanning tree protocol. However, it does per VLAN. So again, Cisco kind of saw that what we really want is the ability to be able to load balance the VLANs so that I can do something like I've got over here. VLANs 1 to 249 are going to take the left-hand spanning tree topology, and VLANs 250 to 500 are going to go the right-hand side, right? And that way, both of these links are being leveraged, they're being used, and we just don't have a link sitting there doing nothing. And so that is the Cisco implementation, right? Now, when we change that, and so if I was to transition back here to this topology or to the switch and get into global config and say spanning tree VLAN, and this is how we change the mode. And we're going to put the range of VLANs in here. So I'll stick with what we had earlier. Let's say that this switch is going to be, for the sake of argument, the root bridge for VLANs 1 to 249. So I'm going to go ahead and say spanning tree VLAN 1 to 249. And you can see here that I can set it as the root, right? I can say root primary, but we don't want to do that. That's a macro. I want to do what the Cisco best practice is, and I'm going to say priority, and I'm going to set the priority to the lowest possible value. Now, all 249 of those VLANs don't exist. So this is just kind of showing you that would make this switch the root bridge. Now, what about the mode? If I say spanning tree mode, there are my three options, right? I've got multiple spanning tree, I've got per VLAN spanning tree, and then rapid per VLAN spanning tree. Those are your three options on Cisco switches. So I'm going to say rapid pvst, and that changes the mode. If I say do show spanning tree, you can see here that now it says spanning tree enabled protocol, rapid spanning tree protocol. What if I say do show spanning tree summary? And let's take a look. It shows you right here. It's RPVST mode. So the switch is in rapid per VLAN spanning tree mode. This is the Cisco implementation of this, right? Of the 802.1W standard. Cisco took it and then they added their secret sauce in. The problem is, or I should say the challenge, is that we now have, or we're going to have, 500 instances of spanning tree, one for every single VLAN that exists in the topology, right? And so everybody kind of realized that, again, you've got the IEEE at one extreme over here, one instance of spanning tree for all your VLANs. And then you got Cisco over here saying, no, a single instance of spanning tree for every single VLAN, right? So there's got to be a happy medium in here somewhere. Where might that be? And that's when everyone kind of came to their senses, again, led by Cisco, with multiple spanning tree. Now, it started out at Cisco as multiple instance spanning tree protocol, or MISTP, right? But the IEEE came in and said, okay, let's standardize this as 802.1 lowercase s. and that is the IEEE Multiple Spanning Tree Protocol. And it's referred to many different ways. If you say MST, people are going to know what you mean, but you might see MSTP, you might see MISTP. I'm sorry, I'm drawing with my mouse here, STP, and you might see just MST. And they all sort of refer to the same thing, the Multiple Spanning Tree Protocol. And this is really the protocol where everyone, like I said, sort of came to their senses and they're like, well, you know, there's got to be a happy medium in here somewhere. And this is what they came up with. Now, again, on Cisco devices, it's just referred to as MST or MSTP, right? And the mode that you'll see, it says change mode to MST, multiple spanning tree. And what it is we can create instances of spanning tree, right? One or more. And in those instances, I can put the VLANs of my choosing. So instead of one instance of spanning tree for all the VLANs, or a single instance of spanning tree for every single VLAN, what we have here with multiple spanning tree is an instance for however many VLANs I want to put in there. And so what we could do over here, and let's change our color now. And we're going to do this yellow-green color and see how that, well, let me see if that, I'll make sure it's not, okay, it's not too close to the yellow. All right. And so what we can do is we can create multiple, I'll just say, let's say instance. I can create spanning tree instance 1. And in instance 1, I can put VLANs 1 to 249. And then I can create a second instance of spanning tree called instance 2. And in that instance, I can put VLANs 250 to 500. And then who knows, maybe you've got a lot of VLANs and you create instance 3. And that's going to be VLANs 500, 501, I should say, 501 to 1,000. You get the idea. And the idea being is that we can create instances of spanning tree into which we place multiple VLANs. And so that allows us to maintain the ability to do load balancing while at the same time we don't have a single instance of spanning tree for everything, but then we don't have 1,000 instances of spanning tree, one for each VLAN. Here we have 3 instances, and into those instances, I've placed the VLANs that I wanted to place. And this is MST, multiple spanning tree, because at the end of the day, in a well thought out network like this, where you have an access layer, and the access layer connects up redundantly to 2 distribution layer switches, there are only 3 possible spanning tree topologies up there. That's it. You've seen 2 of them right here. The last one, which we'll draw out with the green marker. And so here's where I don't want you to think that this is what you would do. You would make these distribution layer switches. One of them is going to be the root bridge. One of them is going to be the secondary root bridge for a set of VLANs. And we're going to do this with multiple spanning tree. And one would be the backup root, or the secondary root bridge and the primary root bridge for the other set of VLANs that you're dealing with. And again, if you had multiple sets, you could just evenly divide it up. So this is just to show you that there are only 3 possible topologies here. So if A1 is the root bridge, well, that means that this port would be a designated port because all ports on the root bridge for the VLANs for which that is the root bridge are designated ports. This would be our root port here for D2. This would be my root port for D1. And this is what we don't want to have happen, right? Is that one of these is going to be blocking up here at the distribution layer. We want our distribution layer to be able to pass traffic back and forth. It's at the access layer that we would want to have one side or the other blocking. But I'm just showing you this to show that in this configuration, which is, again, a recommendation where you've got an access layer with redundant connectivity up to your distribution layer, that there's only 3 possible spanning tree topologies that can occur here. And so now we get down to D1 and D2. Let's just say D1 has the superior bridge protocol data unit, because the first tiebreaker, which is the lowest route path cost to get to A1, is a tie. So D1 is better, meaning this is the designated port, meaning that if A1 is the root bridge, that is a blocking port, right? Okay, so there are the 3 possible topologies that we can have. And so, as I said, Cisco and the IEEE came up with the multiple spanning tree. Again, it was IEEE following Cisco's lead here. Cisco had developed this initially, and then it was standardized. And this is a great, happy medium. The challenge with multiple spanning tree is it's a little bit more difficult to configure. All right, so that's kind of a history and a background of the spanning tree protocol and the iterations of the spanning tree protocol. And it's very, very important to point one thing out about multiple spanning tree. And that is that multiple spanning tree, and I like to think of it as sort of a configuration wrapper. And what I mean by that is multiple spanning tree is not some brand new, newfangled version of spanning tree. Multiple spanning tree is a different configuration syntax that is still under the covers, under the hood, running rapid spanning tree protocol. That is all multiple spanning tree is each of these instances that we create is nothing more than an instance of rapid spanning tree protocol under the hood. That's what it is. And you'll see the configuration difference here in just a second. So I'm going to save this. If you wanted to screenshot this, I'll go ahead and save this for right now. But let's go ahead and transition back over here to ALSW, the access layer switch that we went ahead and decided was going to be the root bridge for a series of VLANs, and we changed the mode to rapid pvst mode, which again, that's Cisco's implementation of 802.1w. Now, you saw just how easy that was. If I came over here to ALSW02 and I said, get into global config, spanning tree mode, rapid pvst, that's it, we're done. I just changed the spanning tree mode, right? That's how easy it is to change the mode. With multiple spanning tree, that is not the case. There's a little bit more thought that has to go into that. And so for this demonstration, I'm going to transition over to, as we'll let those inconsistent errors fly around there, I'm going to transition here over to Cisco Modeling Labs, or CML, right? Now, I apologize, the print is going to be a little small here, and there's not an easy way for me to make that much bigger. Yeah, there's really not a way for me to make that much bigger. And let me try to move this diagram here. And here's the diagram that we're working with. Here's my access layer. I've got a PC hanging off here, and we've got these 2 distribution layer switches. And so what we're going to do is I'm going to walk through an MST multiple spanning tree configuration to show you what that would look like and why it would make sense. And again, I only have a single PC down here, but I want you to kind of use your imagination and think maybe there are other access layer switches down here with lots and lots of VLANs. And I'm only going to configure VLANs 10, 20, 30, and 40 so that those VLANs exist so that we can see what that would look like. So here I am on ALSW01. Now, the first thing I'm going to look at is my connectivity. So gig 00 and gig 01, those are the ports that I connect to the 2 distribution layer switches with. Because remember, we want these to be trunk ports. And what kind of ports are those right now? Well, let me say show interface or interfaces gigabit 00 switch port. This command is a very, very important command, Because when we look at this, we see the administrative mode of the port, and you can see it's set to dynamic auto. This is in reference to the dynamic trunking protocol. And this is Cisco proprietary. It's DTP, Dynamic Trunking Protocol. And the dynamic trunking protocol has some modes. Two of those modes are dynamic desirable and dynamic auto. With dynamic auto, and this is on newer Cisco switches, and not that new, this is dynamic auto has kind of been the default for a while now. What that means is when I plug these switches together, one of the major misunderstandings that learners have is they think, oh, well, those are trunk ports now. No, you can see right here, what is the operational mode of that port? It is a static access port, because if both sides are dynamic auto on a port that are on the ports that the switch is plugged together, neither side will become a trunk port. Dynamic auto, I want you to think of it like this. Dynamic auto is sort of similar or akin to somebody sitting there saying, well, I'll be a trunk link, but only if you tell me that we're going to be trunk link, or that we're going to be a trunk link. And if both sides are saying that, then neither side's going to become the trunk. No, neither side will be a trunk port, right? So we won't have a trunk link. There'll be no trunk port there. It'll be access ports. And really all we've done, because the only VLAN that we have configured, if I say show VLAN brief, all of the ports, oh, and it looks like there's a VLAN that was created by mistake there, VLAN 100, but all of the ports by default are in VLAN 1. So all I've done here is expand the diameter and the size and the scope of the VLAN 1 broadcast domain. And think of a VLAN as a subnet, as a broadcast. Those are so synonymous terms. A VLAN is a subnet, is a broadcast domain. And if all of these ports are access ports, and all of the ports on a switch by default are in VLAN 1, I've just basically created this huge VLAN 1 broadcast domain, right? But that's not what we want. We want to create some VLANs to segregate traffic, and we want to be judicious about that. So let's get into global config with configure terminal or conft. I'm going to say VLAN 10, and actually I'm not even going to give these names. So we'll say VLAN 10, VLAN 20, VLAN 30, and VLAN 40. And then I say end. And now let's say show VLAN brief. And when I say show VLAN brief, you'll see that we've created VLAN 10, VLAN 20, VLAN 30, and VLAN 40. Now, more importantly, we haven't addressed the trunk link issue. So let's go ahead and do that. Let's get into global config. I'm going to use the interface range command. I'm going to say interface range gigabit Ethernet 00 to 01. Now I'm running whatever commands I'm running are running simultaneously on gig 00 and gig 01. And here's the commands we're going to run. We're going to statically configure this to be a trunk link. So switch port mode trunk. That, oh, and the encapsulation is set to auto. And so here's what we need to do. We need to say switch port mode trunk. I'm sorry, switch port trunk in cap, switch port trunk in cap, and we need to change the encapsulation. Now, when I do a question mark here, again, this is an older simulator here in terms of iOS image that they've got loaded here, so you still see ISL. That's that Cisco proprietary inner switch link. And in order for me to do my static configuration, we're going to say switch port trunk in cap .1Q. Want to change it to 802.1Q. So now I can say switch port mode trunk, and that statically configures both of those links on the access layer switch to be trunk links. Now, another thing I'm going to do, and learners always get confused by this, there's a lot of features that Cisco enables by default on their hardware. Features that they then, in a best practice guide, will tell you to disable. Dynamic trunking protocol is one of those features. And the reason for that, the disabling of it, is we don't want to leave things to chance. If the link is going to be a trunk link, statically configure it to be a trunk link. If the link is going to be an access port, or if it's going to be a trunk port, if it's going to be an access port, statically configure it to be that. Don't leave it with dynamic auto or in older Cisco switches, which you probably shouldn't have in your operational environment, dynamic desirable mode. You don't want to leave things to chance. Make sure it's deterministic, that you know what the outcome is going to be when something's plugged into that switch and what the port mode means. So I've just statically configured it to be a trunk port. So now what I'm going to do, I said switch port mode trunk. So now what we're going to say is switch port no negotiate. And that turns off DTP. If I were to scroll back up here just a little bit, when we were looking at that switch port or the show interface gig 00 switch port command, you will notice that the negotiation of trunking is on. Watch what happens. And what that line means, negotiation of trunking on, means the dynamic trunking protocol is on. We want it off, and that means don't negotiate it. No negotiate. I hit enter. Let's say do show interface gigabit Ethernet 00 switch port. And here it is. And what do we see now for the negotiation of trunking? It is off. We've turned the dynamic trunking protocol off. Take a look at the administrative mode. We have statically configured it as a trunk. It's no longer dynamic auto or dynamic desirable. It's hard-coded as a trunk link. That is what we want, and that is the operational mode, right? So for right now, we're good on the access layer switch. I'm going to move a little quicker here, and let's dive into the distribution layer switch. So we'll hit enter a few times. We'll get into privilege exec, into global config, and let's go ahead and say VLAN 10, VLAN 20, and we'll bring that back, VLAN 30, and VLAN 40. Now you might be asking yourself, could I do VLAN trunking protocol, VTP, V as in Victor, VTP? And I could, but again, small topology, this is going to not take us too much longer to get knocked out. So I'll say VLAN 10, 20, 30. I'm going to go into interface range, and actually before I do that, I need to see which ports are connected to the switches, gig 00 and gig 02. So we're going to go ahead and say interface range gigabit Ethernet 00, comma gigabit Ethernet 02. And once again, we're going to say switch port trunk in cap .1Q. I'm going to say switch port mode trunk to hard code it as a trunk port, and then say switch port no negotiate. Could I limit the VLANs that are allowed to transit the trunk link? I could with the switch port trunk VLAN allowed, but we're not going to go into that right now because we're just trying to get this set up. And so then we're good right there. And let's come over to this distribution layer switch DLSW2, and let's do the exact same thing that we just did on the other two switches. We're going to say VLAN 10, VLAN 20, VLAN 30, and VLAN 40. And then we're going to go into interface range, and I need the ports here, and it's going to be 01 and 02. So we're going to say interface range gigabit Ethernet 01 and 2. And we're going to say switch port trunk encapsulation .1Q. I'm going to say switch port mode trunk, and then switch port no negotiate, right? So all of those links between these three switches here, the distribution layer switches and the access layer switch, these are all trunk links now. And how can you check that? The easiest way is to say do show interface trunk. And that's going to show you if you've got trunk links. And this is going to give us some good information. We see the mode is on. And that means it's hard-coded as a trunk link. It's statically configured to be a trunk when the mode is on. We've got our encapsulation. We're using 802.1Q, right? And again, that is the only encapsulation on newer Cisco switches today for our trunk links. The status is it's trunking and the native VLAN is 1. And we're not worried about the native VLAN right now. Now, the most important output here is down at the bottom, or I should say the additional important output is down here at the bottom where it says, what are the VLANs that are in spanning tree in the forwarding state and not being pruned? And you can see it's 1, 10, 20, 30, 40. And of course, 100's in there. And in fact, I'm not even going to delete 100. We're just going to leave it in there for now. And so that's a good thing, right? So let's say do show span, because remember, we're currently running Cisco's implementation of the original legacy 802.1d spanning tree, a version of spanning tree that isn't even referenced in the new IEEE or the latest IEEE document that details spanning tree, right? So again, it's an older technology. You should not even be using legacy spanning tree. At the least, right, you should be using rapid per VLAN spanning tree, or the IEEE's 802.1w, which on Cisco devices was implemented as rapid per VLAN spanning tree plus because of the 802.1q trunking encapsulation. So, but take a look here. My point here is I want you to now think about, we've got like 5 VLANs configured, right? Well, look at that. So this is for VLAN 1. Now we've got a spanning tree output here for VLAN 10, followed by spanning tree output for VLAN 20, followed by spanning tree output for VLAN 30 and VLAN 40, because remember, Cisco is all about per VLAN spanning tree, creating an instance of spanning tree for every single VLAN, right? Which again is way over here on this edge of the extreme. Now, it allows us to load balance, but this is really not what we want to do, right? We don't want an instance of spanning tree for every single VLAN. And that's where the happy medium comes in. So now that we've got these trunk links, and I'll get out of the interface range mode here. Now that we have the trunk links configured, we can configure multiple spanning tree. And I'm going to create, in, again, a well-designed network where you've got your access layer connected up to your distribution, and maybe it's a collapsed, distro core layer, but still, you have the redundant connectivity out of that access layer up to your distribution layer. There's only 2 topologies with spanning tree that I could run. And so I'll create an instance that's going to go on the left-hand side, meaning that DLSW01 would be the root bridge for that instance. And then DLSW02 would be the root bridge for the other instance, instance 2, right? So we're going to create instance 1 and instance 2. And in instance 1, we'll put VLANs 10 and 20. And in instance 2, we're going to put VLANs 30 and 40. Again, VLAN 1 and VLAN 100, we're just going to leave out for now. And that would allow me to simply have 2 instances of what is really rapid spanning tree. It's rstp, right? Because remember, the IEEE 802.1w rapid spanning tree protocol is all VLANs in that instance are in a single instance. And that's all we're doing here. Except now we have the configuration ability with what I refer to as kind of like the wrapper, how we kind of trick spanning tree into saying, well, this rstp instance for multiple spanning tree, you're going to get these VLANs. And then this other instance is going to get these other VLANs. And you're going to see what I mean right here. So here we are in the command line. And the nice thing about multiple spanning tree is I can configure everything, stage it, get it all ready to go, and then flip the mode, that spanning tree mode command that you just saw, right? If I said spanning tree mode, and I could pick MST. And that's what we're going to do. We're going to configure and get everything staged. We're going to go in this little circle here from access layer 1 to distro 1 to distro 2. And then we're going to come back to the access layer, kick it on. And it's backward compatible with the other versions of spanning tree. That's one of the great things about spanning tree is whether it's pvst plus or rpvst plus or MST, which again is just rstp under the hood, they're all backward compatible, but you would not design a network with the idea that, oh, on this switch, I'm going to run per VLAN spanning tree plus over here on this other switch, rapid per VLAN span, and then MST. You wouldn't do that, right? You'd want to keep it all the same. And hopefully that makes sense, that that's an obvious point. So here's what we're going to do right now. Let me actually get a quick sip of water here. Now we're going to go ahead and create our multiple spanning tree. So we're going to say spanning tree, oops, MST, sorry, MST and configuration. There we go. And so that puts me into multiple spanning tree configuration mode, where now I'm going to be able to create my instances, assign the VLANs to the instance. We're going to create a name for this multiple spanning tree instance, and I'm going to talk about the revision number. Now, Before I do that, with multiple spanning tree, as you're about to see when I say show current, you're going to see an MST0. And that's multiple instance spanning tree 0, also referred to as IST, right? And the IST is the instance of spanning tree that you would run if you were connecting up. That's going to be the spanning tree that would be connected up to maybe another domain, maybe a service provider, maybe a switch that's not running MST, that's not in the MST region, so to speak. So first thing we're going to do is we're going to give this a name. We'll just say CCIE lowercase mode, and then we're going to give it a revision number. Now, the revision number is something that's there for you to manually, I stress that, manually update. When I go in and make changes to multiple spanning tree, that revision number is not automatically updating for me. It's there for me to go in and say, okay, I made a change, and now let's change the revision number from 1 to 2. So we'll just start out with revision 2, right? So then what we're going to do is I'm going to say instance. Now, you can see we can have from 0 to 4094. Again, 0 is already there, and you don't want to use 0 for the other VLANs that are around, right? And instance 0 by default holds all VLANs. In fact, from here, well, actually we're in the instance, let me back up just a second here. From here, if I was to say show current, and I just talked about that, but let me show you. You can see instance 0. Instance 0 exists right out of the gate, right? As soon as you go into configuration mode, it's there, and all VLANs are mapped to instance 0. And anything we don't map into our instance 1 or our instance 2 is going to be left in instance 0. And that's okay, because like I said, if we were to be connected to another device that's not running multiple spanning tree, it is this common instance, the IST, the internal spanning tree instance, that would take care of that for us. So here we are. Let me go ahead and say instance 1. And if I do a question mark, you can see we can put the range of VLANs. And so for instance 1, I believe I said 10 and 20, right? So instance 1, VLANs 10 and 20. And then for instance 2, for this rapid spanning tree protocol instance, right, where originally all VLANs went in there, now we have the configuration option where I can go ahead and say instance 2 is going to be VLANs 30 and 40, right? Pretty cool. Okay. So now if I say, sorry, let's just go back and say show current, right? You'll notice that nothing has changed because show current is different from show pending. When I say show current, it's what is spanning, how is spanning tree operating right now? What is the operational state? Show pending will show me, are there any changes that might be made, that are pending right now in the topology? And so I say show pending and take a look. You can see that changes have been made. They just haven't been committed yet. And we can commit them by simply exiting out and then going back into, I could also say abort. Abort is an option here. Yeah, you could say abort and I could bail out. If I say exit, I exit the region configuration mode, right? Because remember, this is going to be our own little spanning tree region, and that applies the changes. We've done the mapping, we created our name, and so let's go ahead and do that. Let me say exit. And there we go. And so now we're out of that mode. Let's come up here and let's do the same thing on the distribution layer switch, albeit we'll do it a little bit faster. So let's get into privilege exec, let's get into global config, and let's say spanning tree MST configuration. Once we get in here, we'll give it a name, CCIE. We'll give it the revision number to make sure the revision number is the same across the board so that we're tracking things here. Revision 2, and then we'll say instance 1 is going to be VLANs 10 and 20, and then instance 2 is going to be VLANs 30 and 40. And you can see, right, that there's a little more involved than what we were doing with either per VLAN spanning tree or rapid per VLAN spanning tree. Here we got to get in again. And like I said, I look at this as like a wrapper syntax, right? That, you know, or a macro that behind the scenes, it's like, oh, okay, these VLANs are going to be with this rapid spanning tree protocol instance, and these VLANs are going to be with the other rapid spanning tree protocol instance. And then we're good, right? So there we go. And so if I was to go ahead and say, show current, we would see what we would expect to see, which is, you know, just that setup right there. If I say show pending, we're going to see our pending changes. I say exit, I've committed my changes. Let's come back up here to this distribution layer switch. Let's jump on the console. And we'll go from user exec to privilege exec into global config. And we're going to say spanning tree, spanning tree MST configuration. And again, we're going to throw a name on here, CCIE. We'll give it a revision number of 2. And then we'll map our instances, right? We're going to go ahead and say instance 1 is going to be VLANs 10 and 20. And instance 2 is going to be VLANs 30 and 40, right? And I say exit. So now none of this has taken effect yet. Remember what I said. We can stage the entire configuration. So if you were like thinking about, we got to do a migration, and there are some best practices for migrations. If you were going to do a migration, how would I do this? What am I going to need to do? You can do all of this. We haven't changed the spanning tree mode yet. Do show spanning tree summary is still going to show me IEEE, right? Or Cisco's pvst mode when I run the summary command, or if I was to say do show span for do show spanning tree, we see that we're still running legacy IEEE 802.1d Cisco style, right, with pvst plus. That's what we're running. Nothing has changed here, right? Now, my configuration is set up and ready to go. And let me go ahead and say do show spanning tree MST, and I can say, whoops, the switch isn't in spanning tree mode, and that's another way to show you that it's not. Once we activate it, this is how we can take a look at what is in there. So let's do that. Let's go ahead and we'll start at the distribution layer switch here. Spanning tree mode, MST, right? Let me come down here to the access layer switch, and let's say spanning tree mode, MST. And we'll come up here and we'll say, we'll say spanning tree mode, MST. All right, so now if I say do show spanning tree, MST, sorry, keep blacking out there on the MST. All right, now take a look at that. So here is MST 0, right? And you can see right up here, all the VLANs that we didn't touch are in MST 0, and that is just fine. And that is the common internal spanning tree, or the CIST, or sometimes you hear just IST for the internal spanning tree. But as we come down, take a look. MST1, what are the VLANs mapped? Well, it's 10 and 20. And for MST2, what are the VLANs that are mapped? Well, it's 30 and 40, right? And you can see they're also doing the long cost, right? And this is another nice thing, is we don't have to manually choose between the sort of legacy spanning tree cost of each of the ports, or the ports based on the speed of the port. Here, it's already set for us to sort of the current way that you would want to do it, with faster link speeds, right? Because with spanning tree, once you get to 10 gigabits a second per port, anything faster than 10 gigabits a second, the cost with the legacy, with the short costing model, is 1. And the problem there is, if you've got 40 and 100 gig, they look the same in terms of cost from a spanning tree perspective as your 10 gig, right? And you don't want that. You want to be able to differentiate between those. All right, so we would think, right, that things look pretty good. So let me say do show spanning tree root. And we're on the first distribution layer switch here. And you can see that for the multiple spanning tree instances, the root cost is 0 for all 3 instances. And what that would mean, if I say do show span, oops, sorry, not do SSH, do show spanning tree, what we get here is you can see that it just so happens that for the multiple spanning tree protocol, and take a look what it says now, spanning tree is enabled protocol MSTP, right? That this bridge just happens to be the root bridge. However, the problem is, remember what we said. What did we want to have happen? We want instance 1, right? And so I'll just say instance 1 to use this as the root bridge, but we want instance 2 to go the opposite, or VLANs that are in instance 2 to go the opposite direction and to have this as the root bridge. But we don't have that right now. Where are we at here? What we have is that the distribution layer switch 1 is the root bridge for all instances, right? So how do we fix that? Well, let me first turn off the drawing tool. And so what we're going to do now is we're simply going to come in here, and on this switch, I'm going to say spanning tree, MST, and then the instance number 1, and let's do a question mark. And you can see I can say root primary, which again is a macro, meaning I say root primary and then it adjusts the priority based on some values that may or may not be set throughout the environment, and it'll drop it down to right around the middle range of the possible priorities. But we want it to be deterministic. We want no question that if it's the root bridge, the priority is 0. And then for instance 2, we want the priority to be 4096, right? And that is how we set the priority on DLSW01. So now let's recall that do show spanning tree root, and let's see what we see now. Well, take a look. You can see here that we've got the root cost listed out, for MST1, you can see that the root ID has dropped, right? It's not 32768 is no longer the priority. The priority shows 1 here, and we see 4098 down here. Now we're going to come over onto DLSW02, and we are going to do much the same thing. We're going to say spanning tree MST 1, and we're going to say priority. Sorry, I'm saying root. We'll say priority, and this is going to be 4096, because again, this is going to be the secondary root or the backup root bridge for the VLANs that are going on the left-hand side in instance 1. And then we're going to say priority 0 for instance 2, right? And that's going to guarantee that those would be the root bridge and the secondary root bridge for the respective instances. Now let's come down here to the access layer, and let's see what the access layer switch sees. And let me save the config here just real quickly. And let's see what the access layer switch sees when it comes to spanning tree. So if I say show spanning tree now, you can see that we have MST0. But when we get down here to MST1, you can see that it says that the root bridge, and it lists out the root bridge port out which it goes here, which is gigabit Ethernet 00. If I was to look at connectivity, where does 00 go to? It goes to distribution layer switch 1. So for instance 1, distribution layer switch 1 is the root bridge. If I come down here to, and let's keep going down here, to MST instance 2, take a look at this. For instance 2 and all the VLANs in instance 2, which switch does the access layer switch believe is the root bridge? Well, it's out port 2, gigabit Ethernet 01, meaning this right-hand side over here. And so this is the happy medium. And again, if I was to say show spanning tree MST, and you could break it down into instance numbers, right? I can say config, oops, sorry, not config. Let's say config. And there is the spanning tree configuration. I could say do show, show spanning tree MST, and then I could put the instance number. So what if I wanted to see things about instance 2? All right, well, there's the instance 2 information. And again, this is just sort of paring down the show spanning tree. which ran and gave us a whole bunch of information. We could also do a detail, MST detail. And you can see we're going to get much more information here, right, that we might be interested in, a lot of port information. And again, a lot of detail that's going to come out of that for multiple spanning tree. But again, at the end of the day, in a configuration like this triangle configuration here with the access layer redundantly connected to the distro layers, there's only 3 possible topologies, and there's only 2 that we're interested in. One using the link on the left, one using the link on the right. All right, so here's how we're going to finish up. We're going to talk real quickly about Etherchannel. And I'm going to go ahead and let me clear the screen there. And we're going to do this on these access layer switches here. Right now, remember, I said, when I say do show spanning tree, you can see that we're only interested in fast Ethernet 09 to 24. Now, with Etherchannel technology, there's 3 ways we can do it. We can use 2 protocols, which are PAGP, Cisco proprietary, not very popular. The port aggregation protocol is what that stands for. We could use LACP, which is 802.1 capital A, capital X, like AX, AX. And that is Link Aggregation Control Protocol, which is an open standard, which is very popular. And one of the reasons it's very popular is both of those protocols can have a maximum of 8 active links in the bundle of links. However, LACP allows you to bundle up to 16 links, of which 8 are active. And you can have 8 hot standby links. So if you cannot afford to lose bandwidth for whatever the reason is, LACP is probably the way to go because you can have hot standbys. And I'm going to show you that right now. So let's go ahead and dive in here. I'm going to get into global config, and I'm going to say interface range fast Ethernet 09 to 24, right? And here's what we're going to do. I'm going to say switch port trunk encap. Oh, that's right. This is a 2960 where the only encapsulation is 802.1q. So I'm going to say switch port mode trunk, and I'm going to say switch port no negotiate. So I basically just made all of these trunk ports and turned DTP off on all of these ports. And as you can see, we get a whole bunch of messages here. Now, this is one way to go about it, because what I'm about to do now is I'm going to say channel group, and you can see on a 2960, again, lower end switch, we can create 6 ether channels, right? Not very many. With like something like a 6800 series or something like that, you're going to, like a distro layer switch, you're going to be able to create a lot more ether channels. Here, I'm just going to create the 1. So we're going to say channel group 1. The number does not need to match on both sides. However, as I always say, you would be crazy not to match the number up. It's going to make troubleshooting really difficult if you've got a bunch, 6 ether channel links configured here on the 2960, and you're using one set of numbers on one side and another set of numbers on the other side. That's going to get complicated, right? So channel group 1 mode, and let's do a question mark. So here are the different modes. So active and passive are LACP, right? And you can see that right here. Just like the dynamic trunking protocol, auto and desirable. This is the Cisco PAGP protocol. And you've got auto and desirable mode. Now, the final one is on. And what that means is be an ether channel, right? Aggregate the links together and do it unconditionally. Meaning there's no protocol checking to make sure that things are working and that everything's going well and that one side, we all meet the same requirements. No. On means just turn ether channel on. And this is something that I avoid at all costs, right? I'd like having a protocol there to do the checking for things to make sure that everything is kosher and that everything is going to function properly. So we're going to say channel group 1 mode, and I'm going to make this side passive. Now, before I hit enter here, if we roll back up here, you'll notice that on this side, 09 through 24 are all designated ports, meaning they're all capable of forwarding traffic. Over here, it's a little bit different. If I say show spanning tree, And I wanted to show you this initially here, because take a look at what Spanning Tree does. And so to give you an idea, these are two 2960s I have, physical switches in my lab that have 16 Ethernet cables run between them. So fast Ethernet 0, 9, and the first switch goes into 9 on the second switch, and then 10, and then 11, all the way to 24. And look at what Spanning Tree does, because this is one of the advantages of doing Etherchannel. We're going to take a series of individual physical ports, and we're going to bundle those together into a single logical port, which is referred to as a port channel. Okay. And I use port channel and ether channel and lag, link aggregation group. They're synonymous terms, right? Link aggregation group, port channel, ether channel, I use them as synonymous terms, right? It means a bundle of physical links that we use to create a single logical link. But look at what Spanning Tree is doing. And Spanning Tree is doing exactly what it's supposed to do. We have all these redundant links running between these two switches. Spanning Tree is blocking all of them except one. That's what Spanning Tree does, because it prevents the loop, right? So to get around this, we can use Etherchannel to put all of these ports into an Etherchannel using LACP, and we'll have 8 active ports with 8 hot standbys. So let's finish that out. So I say channel group 1 mode passive, right? And you can see right there, creating a port channel interface, port channel 1. So let me go ahead and say do show run interface PO1. And you can see that there's nothing under the configuration there. And I did this intentionally so that you could see this. But if I was to say do show run interface fast Ethernet 09, it says here, switch port mode trunk, switch port no negotiate. But under the port channel, there's no config, because what I just did here is kind of the opposite of how you would really want to do it. And let me say interface PO1, and I'll say switch port mode trunk, switch port mode trunk, and then switch port no negotiate. So if I said do show interface PO1, do show run interface PO1, it now says switch port mode trunk, switch port no negotiate. But we would want that to happen auto-magically. And watch what happens here. So I'm going to come over to ALSW02. We're going to get into global config. I'm going to go ahead and say interface range fast Ethernet 09 to, it was 24, 09 to 24. And what I could say here is I could throw the channel group command on here. So what if I said channel group 1 mode. Now, if the other side's passive, or if the other side, if we're doing PAGP, if the other side's auto, the opposite side has to be for PAGP, it would have to be desirable, or for LACP, it's got to be active, right? Because we did passive on the other side. So one side's got to say, hey, we're going to set up an ether channel here, right? Let's do it. And that's what we do here. However, keep in mind, you cannot mix and match each side. So one side can't be PAGP and the other side LACP, or PAGP and on, or LACP and on. You can't mix and match. Each side for the respective links needs to be the same ether channel protocol, right? Or on mode. All right, so I'm going to say channel group 1 mode active. And you can see that it creates the port channel interface, the logical interface, because we're going to trick Spanning Tree into thinking that all 16 of these ports, that they don't actually exist. There's only one port that really exists. It's PO1. But here's what I wanted to show you. You'll notice I didn't say switch port mode trunk. I didn't say switch port no negotiate. Because if I say do show run interface port channel 1, you'll notice the commands aren't there because I never ran those commands. If I say do show run interface fast Ethernet 024, those commands aren't there either. But what happens if I go into interface port channel 1 and say switch port mode trunk and switch port no negotiate? And you can see here the interface is going to go down, and we'll give it a second. And then all those interfaces are going to come up. And the port channel is going to come up, right? or the port channel interface is going to come up. So now watch what happened. When I made the change under the port channel interface, do show run int po1, it auto-magically pushes that exact same configuration information down to all the member ports. So for 24, 23, or for 22, fast Ethernet 024, 023, the switch port mode trunk and the switch port no negotiate got pushed down to those ports auto-magically. So you make the configuration change under the port channel interface, and it gets pushed down to the member interfaces. That is how you want to do it. And again, I wanted to show you how it's not that you can't do it the other way. It's that it just becomes a little bit more tricky when someone's looking at the port channel interface and doesn't see any config. Then they've got to go look at the member interfaces to figure out, well, what's the config on those member interfaces, right? Instead of being able to look at one port channel interface and see, oh, okay, switch port mode trunk, switch port no negotiate. All right, we're good to go, right? So now let's take a look at show Etherchannel summary. And here is where it's going to get good, because here's where you see the ports that we're using. And there are your 8 active ports, fast Ethernet 09 to 016. And as you can see, the P that we have here in the parentheses stands for bundled, and in the port channel. The capital H simply stands for, oops, sorry, not in use, for hot standby. And you'll notice it says LACP only, because you can't do this with PAG-P, and you certainly can't do this with the on mode, right? So we've got these hot standbys in there. You can see the S and the U. The S think of the S as switch, layer 2, and the U meaning it's in use. We're up, we're good here, right? This is great. So now I'm going to show you what happens with the hot standby. And yes, it is going to grab the first available hot standby port. So if I was to go into global config, and let's say I go into fast Ethernet 013, and I accidentally shut fast Ethernet 013 down. You might think that, okay, well, do I have to tell Etherchannel or LACP to bring fast Ethernet 017 online, or to bring one of those hot standby ports online? And the answer is no. And it's right here. Take a look at what happened. Line protocol and fast Ethernet 017, boom, changed to up, and do show Etherchannel summary. It is now an active member in the port channel. Right? So we've got 8 ports still. That is the feature that LACP provides that on mode and PAG-P do not, right? And what is the status here of 13? Well, it's just down, right? And we shut the port down to simulate a failure. So the port is down, right? And this is the beauty of Etherchannel. But the most beautiful part you're about to see, remember, when I said do show spanning tree, I'm sorry, I did that over here on ALSW01. When I said do show spanning tree, and we got to look at all of this, right? To see all of these ports and all of their status here and the cost. And here's our legacy cost for fast Ethernet. It's 100, or I'm sorry, is 19. And the priority numbers and all that, right? And we're interested again in these 09 to 24. Now let's take a look. And let's go ahead and say, show spanning tree. And what do we see? Yeah, that's the entire output for spanning tree. Because what is the interface that spanning tree is interested in? It's not all the member interfaces. And there is no spanning tree reconvergence when a link in the port channel goes down. Spanning tree doesn't care, because as long as the port channel itself is up, in other words, as long as there is at least a single link in that bundle that is up, the port channel interface will be up. Spanning tree is not going to reconverge. That's another huge benefit, in addition to the benefit of having an aggregate amount of bandwidth. And in this case, we've got 800 megabits a second, right? We've got 8 100 megabit fast Ethernet ports bundled together. In terms of bandwidth, this is not throughput. I'm also going to place a link in the description to the video where I go over how Etherchannel determines which link in the bundle traffic transits over, because it's based on source and destination IP, or source and destination MAC address, or all of those things, depending on the model of the switch. And I have a great video where I show you how you can run a test command to determine, based on the values for the source and destination, which link in the bundle it's going to go over, right? Now, do you have to have an even number of links in the bundle? No, you can have an odd number, because what if you had 8 and 1 failed and you had no hot standbys? Well, you'd have 7, and you don't want the bundle to shut down because you've got an odd number. However, for the hashing to kind of work its best optimally, you want to make sure that you're using 2, 4, 6, or 8. You want to have even numbers in there. And you can go onto Cisco's website. They've got a white paper that talks about the hashing algorithm and how it works. All right, well, I've got 9 o'clock, so we went 90 straight minutes here talking about spanning tree. And let's just go ahead and recap what we talked about. We talked about the history of spanning tree. We talked about the different versions of spanning tree. We talked about how really the IEEE does what they normally do. They take a Cisco technology that Cisco's trying to get standardized to be Cisco-esque, and the IEEE says, no, but we're going to go ahead and standardize it so that everybody can use it. And we talked about 802.1d, we talked about 802.1w, we talked about 802.1s, and the Cisco implementations of each of those. We talked about the two extremes, the IEEE saying, no, a million VLAN, and again, I'm just, you can't have a million VLANs, but I'm just saying, yeah, a million VLANs, no, that's all going to be in one instance. And Cisco saying, no, for a million VLANs, we wanted a single instance of spanning tree per VLAN. Again, two extremes. We came down, they met in the center, I kind of say that euphemistically, where it was like, let's find a middle ground here. And that was our multiple spanning tree protocol, where I can create some instances, and then I can put the VLANs into those instances that I want to have in those instances. So I'm not stuck with one instance of spanning tree for everything, and I'm not stuck with instances of spanning tree for everything, right? I can kind of right size the environment. Now, again, use case is going to drive a lot of this. Would you run multiple spanning tree if you had 4 VLANs in your environment? Probably not, right? That doesn't make a lot of sense. You'd run rapid per VLAN spanning tree, RPVST plus. That's what you'd be doing, right? All right, well, that is going to do it for our session tonight. I'm hoping that this is going to provide some clarity around spanning tree, some configuration tasks we looked at, some of the conversation that we had. If not, please drop me a question. And that is all I have for this evening. Everybody have a great week. And remember, the end of week 1 is this coming Tuesday, May 25th at 11:59 p.m. Have a great week, everybody. Thanks for watching, and I will see you guys next week.